from 0 to pi minus the integral of v du. So that'll be plus integral of cosine t dt. Okay. Get rid of the rest of this. So ultimately, what we get, we put it all together, that's sine t plus 1/2 sine squared t minus t cosine t plus sine t evaluated at 0 and pi. So when you plug in your limits, 0 and pi, everything is 0 except for when you plug in pi into this part, you get pi.
Minus pi?
No, because cosine of pi is minus 1.
Okay, I see.
Yeah. Okay.
Hey, I just realized something. Pi Day is the same day as Albert Einstein's birthday. That's kind of weird.
On 3/14?
Yeah,
What day is it?
Really?
because I was just thinking that they're both after mine.
Oh, okay.
It's funny that they're coinciding.
Which,
Yeah.
Which 2 days?
Huh?
What 2 days coincide?
Albert Einstein's birthday and Pi Day, March 14th.
Yeah, in Europe it can't have Pi Day because they put the day, then the month.
Yeah.
Okay. The Diana on Pi Day would always bake pies and bring them into work, and of course her coworkers have no clue what the day was about.
Yeah.
Especially with special observance at 1:59 p.m. But hey, they got to have pie, so they didn't care. All right. All right. So any questions about, especially the setup? All right. So it's a vector field with your parameterization plugged in, dot product with tangent vector when you get by differentiating your parameterization, and that's once you complete the dot product, that's what you integrate. Okay. Now, let's see. Now we take a closer look at what's going on with this dot product. Gives us another way of writing these integrals. It's going to be important later on. Let's suppose that, so we're dealing with, we'll stick with two variables. So suppose your vector field, f of xy, has these component functions, p of xy, q of xy. Okay. And then our curve has this parameterization, x of t, y of t, for t between a and b. Okay. Then if we take a look at this integral, dotted with r prime of t, and now we fill in what all of this is. So we're going to have p and q dot product with x prime of t, y prime of t, dt. So now let's carry out the dot product right here. So we're going to get p x prime plus q y prime. Okay. Now, so a common shortcut for writing this that you need to be aware of, because it's something that's going to be used for the rest of the semester and any time these kinds of integrals are computed. This is the integral over the curve of p, and this x prime of t dt, that's dx, because this conveys a change in x. This dy conveys a change in y, so we get p dx plus q dy. So, yeah, this is kind of weird, but so whereas before we were computing integrals where really with respect to the arc length of a curve, now we're computing integrals with respect to changes in x, or changes in y, or changes in z. And the thing you have to be careful about is, so ds, which is x prime squared plus y prime squared dt, is always going to be positive. But dx, dy, dz can be negative or positive, depending on how the curve is going. So you have to be careful about that. Now the orientation of the curve becomes important. Because if you have a curve like this, so over here, dx is positive. In this region, dx is negative. So you could integrate a function along this curve, going from this point to this point, but then if you go backwards along the curve, so you're integrating the same function over the same curve, but you're just tracing it in the opposite direction, that negates the integral. So I'll call these points point A and point B. So here's a common notation. If this is a curve C, when you're tracing it from A to B, then if you're going from B to A instead, we call that minus C. So the minus indicates the orientation is changed. So if you integrate a function, or a vector field rather, over a curve, then if you integrate over a curve traced in the opposite direction, that negates the integral. Similarly, with what we have here, so the integral of over c of p dx is going to be minus the integral of p dx along the curve traced in the opposite direction. Okay, so
would that give us a negative word if you got a positive word the first time?
well, yes, it would, as a matter of fact. Yeah, because so really what's happening is, if you think of work as being force times distance, now we're talking about signed distance.
Oh, negative distance. Okay.
Yeah. So if the amount of work, it would be the absolute value of that, but now there's a minus sign that's indicating the direction in which the work is being done. Okay. All right. Okay, so now, take a look at this vector field, z, x, and y, and our curve C, t squared, t cubed, t squared, where t goes between 0 and 1. Then, so our line integral over a vector field over our curve can be written as the integral over a curve of z dx plus x dy plus y dz.